Before we get into the new-ish stuff today, so we're not going to, it's going to be more application than actually doing a new thing. Who can give us a refresher on what correlation coefficients are and some things about them? So let's look. One thing about them that you know. Well,
correlation is something that's similar between something and coefficient is a number and a variable.
okay, so we have a number that describes a trend, is how I'm going to summarize what you said. Okay, what else do we know about correlation coefficient specifically then? Raymond, give me one thing.
If a positive slope, then it's a positive.
If what's a positive slope?
The line.
Of?
Best fit.
If the line of best fit's positive, the correlation coefficient is also positive. If the line of best fit's negative, we know that the correlation coefficient is also negative. What else do we know about the numbers and the correlation coefficient? Micah?
They have to do with like how much relevance they have to each other, and kind of like how close they are to like the line of best fit.
Yeah, it's how tight or not tight it is to the line of best fit. And what numbers do we use to represent that?
Residuals.
No, residuals do describe the tightness to line, but that's for each data point. This number describes the whole line of best fit.
Coefficient.
Yep, but what numbers do we use for it? There's a range of numbers we use. Like
Negative 1 to 1.
-1 to 1, and 1 and -1 mean strong or weak.
Strong.
Strong means right on the line. What number do we use? What number do we approach as we get weaker? 0 is the lowest correlation. Okay, so that's a summary of yesterday. Today, what I'd like you to do now is try to look at situations and attach circumstance to the scatter plot. You're going to do like a little mix and match, ABCD to 1, 2, 3, 4, because context is going to determine what's what here with your partner. So here we are with our connect. So again, here's the reasoning. We need context because we could have correlation. Like let's say this could be a graph of like temperatures and no, this could be temperatures in Colorado and cereal in Miami. But would it make sense like that they're related even if it showed this? No, so we kind of need the context. So here, the height's the same whether you measure in inches or feet. Here, in general, not all the time, but you shoot more free throws, you have a higher score. See, this is all just randomness, which would be the unrelated temperatures and cereals. And 4, in general, the longer you wait in an ER, the less satisfaction you have. But maybe some people are kind of satisfied. Maybe they waited a long time just because it was really busy, but they're still appreciative of the care they got late or something, right? So that's why. So which one has the strongest correlation as we look at these? Yeah, this one. Which one has the weakest?
C.
C. Which one has the second highest?
2.
Which one has
4.
the third spot? Yeah. So you can like see by looking, and that's going to relate to the correlation coefficient, that number between 1 and -1, where if the closer it gets to 0, the more random it is. The closer it is to 1 or -1, the tighter it is, right? The stronger. So we're going to use words like strong and weak and stuff like that. Okay. So, right here, thank you. We have Priya. Priya is usually a pretty good go-to math friend. But Priya recorded distances a car has gone and how long it took to go that far. Okay. So what do you think, for number 1, we're going to roll through some of these just together because I don't think these are big, crazy questions. Distance is definitely a factor. What other factors might influence the time it takes to travel somewhere in a car? Will, give me one. Oh, I'm going to say road conditions. Yep. Okay, Grant. Construction, yeah. I tried to write S and T at the same time. Okay, what else? Bob.
The speed limit.
Speed limit, yeah. Which deals with like the type of road you're on, right? Like a city road versus an expressway too, maybe? Okay. Ellie.
Like gas mileage.
Would determine
How much you
how often you'd have to stop. Yeah, I got what you're saying. Stops for gas or snacks. We know Elliot's going to stop for a snack. Micah.
Traffic.
Traffic. Okay, so we have a lot of things, right? Are your kids yelling in the back and you got to pull over, right? Okay. Is there a gaggle of geese crossing the street? Lots of things. Okay. Is that the right terminology or did I just make that up? Okay. Which of these factors do you think is the biggest determinant? Speed limit?
Or just how fast you're driving in general.
Traffic? Stops?
I think it's just how fast the car goes. It's temperature.
I think it's distance.
I thought oh, it's
Okay.
including distance.
Yeah, I think distance is probably the biggest factor. So in general, bring it back, Emmett. In general, the further you have to drive, the longer it takes. In general. Next, you're going to use the link on the slide, the previous slide to this, to Desmos, to get a line of best fit. You're going to then, right here, it doesn't say to do it, but I want you to write the equation of the line of best fit right here. Okay? Then, you're going to interpret the slope and y-intercept. What do they mean in context? Then you're going to find the correlation coefficient. The correlation coefficient is already going to be on Desmos. It is that rho value, the R, rho. And if you forgot what to type in, I'll put it right here for you. Y1 tilde M x1 plus B. That'll get you your line of best fit. You do not need to type in the data. The data is linked on the previous slide. You're going to roll through all these. Then you're going to make a prediction, the 90 miles prediction. So in your math notebook, you are going to complete 3 through 6 right now with your partner. To refocus, the slope is the time it takes to go 1 mile, about 0.93 minutes. And the y-intercept's all the stuff you're doing to get ready. You're getting in, you're adjusting mirrors, you're getting the playlist right, you're getting sturdy, all those things, okay? Maybe you're taking a sip of coffee. So, hey guys, the little side conversation stuff needs to stop because you're slowing us down. Later you're going to be like, man, I wish I had more time for homework. And I was be like, I was trying. All right. Okay. So, the next question. I need to look 2 screens at once here. Who can tell me what the R value is? The rho value. Micah.
0.98 about.
Yeah, it's right there. So that's our R value. It's near 1. So what does that mean?
It's very wide.
Fits very well. Strong, positive correlation is what we would say. Strong, positive. That means the further you go, the longer it takes. Okay? Strong, positive correlation.
Why does it say R squared?
That has to do with you remember like standard deviation? Anyway, we don't need to worry about that one.
Okay.
It's all been there the whole time.
No, I know.
Okay. So next up,
Just press a button.
6 says how long to go 90 miles. What'd you guys say? Raymond, what'd you say?
87.85.
What'd you say? Yeah, I got something like 88 minutes, but I rounded. And here's what I did. I took...
I just said 88.
Hey guys, if you'd like to share, raise your hand. I'll call on you. Okay? But I said about 88. Raymer gave another thing. Regardless if you rounded different, we're good. So, what I said is 90 miles is X. I threw it up in here. This gives me the estimate. And it was about 88 minutes. Is that a good estimate? Raise your hand if you think it's good. Raise your hand if you think it's bad. Yeah. So the line, here's how we know it's good. The line of best fit. Did it fit the data well? Yeah, like actually very well. So the estimates on our line of best fit are going to be really good. Just to throw back to a couple days ago. If the line of best fit is a good estimate, what would we know about our residuals if we have them? Big or low?
Oh, because the correlation is high.
Low. Residuals.
Oh, sorry. I got
Residuals be low. Correlation coefficient would be as big as it can be. 1, right? Micah.
Is it possible to calculate correlation
Coefficient?
or just correlation?
Yeah, yes, but we're going to worry about interpreting it, not calculating it right now. Yep. All right, so we're going to move on to something called correlation zoo. We're going to look at a bunch of different situations, and we're going to work on getting the language to talk about how they correlate. So, it is right. We already talked about all these things. Here, we're going to do number 1 together, and then you're going to do the rest with your partner. So number 1, number of steps taken per day, number of kilometers walked per day. Here's our correlation coefficient, 0.92. So 0.92 means what?
It's a pretty strong positive.
Strong and positive relationship. Okay? Now, the second part, you're going to say what it means in context. And here's what I would say, or how they're related. And I'm going to write, I can't write all the words because I don't have a ton of space on here, but I'm going to say something like an increase in kilometers goes up with increased steps. So I'm going to make a statement like this. Like, as this increases, this also increases. Strong positive. So you're going to make a statement. You're going to do this for all the rest of the 5 of these. Okay? So you're just going to say what your correlation coefficient means and what it means in terms of relation to your variables. All right? I think this should only take about 6 minutes. Thank you, Chuma. Thank you, Evan. Thank you, Ellie. Thank you, Evan. Okay, so again, we shouldn't really need computers now for this. We can look up here. Number 2. I'm looking for the words to describe our correlation. Willem. Yeah.
The temperature goes up, the band's ability to stretch goes up.
Okay, I'm summarizing what you said just so it can fit on here. I said strong positive, that's what SP is. As the temperature increases, so does the elasticity of the rubber band. We're good? You have a question about that, Spencer? Now you want the next one, okay, Spencer? Car weight.
It is a strong negative.
Strong negative, okay, and what does that mean?
As the weight increases, the distance traveled decreases.
Yeah, and why would that be, Spencer?
Because they have to, because it's more weight to carry.
Yeah, if a car is heavier, it gets worse gas mileage, right? Okay. Number 4. Hadley.
It's a moderate positive.
Moderately positive. Yeah, or kind. Yeah, that's a good word choice. Moderately positive. Okay, what does it mean?
Could it be a strong positive?
It's not strong. Not quite strong.
As fat intake increasing in the country, the increases cancer rate and said country increases.
And I'm going to say, but not strong. Something like that. So yeah, it looks like there's a correlation. Does that mean that fat intake increases cancer?
No.
We don't know, but this just shows that there is a trend. You're going to hear this term, and we're going to talk about it tomorrow as well, where correlation does not mean causation. It's not always the cause, but it would mean something to look into, kind of thing, right? So there is correlation. So this would say that this is the correlation, but maybe it's not the cause. Maybe it is though. It's cause to look into what the cause might be. Number 5, Micah.
I just said that my mom and I were kind of talking about this all the day.
What's that one saying? Stella?
That's a weak positive.
A weak positive. Okay? And what is the weak positive saying in context?
That the number of words that you put in your essay didn't define yourself.
So words up, I'd say score up, kinda, or a little, right? There is some correlation, but it's not universal. And that makes sense too. You've probably heard this from language arts teachers too, when you have an essay and you're like, how much do I write? And they're like, it matters more what you write than how much you write. You know that statement? That's probably where that comes from. Will, last one, hit me.
The average time spent on music per day is
What kind of correlation we got?
weekly negative.
Weekly negative, which means more music, right?
More music means less TV.
Trends down.
Is time for music competing?
TV time. But,
Barely.
yeah, but barely.
Probably backwards.
So there's like some correlation, but like not very strong. And probably because when you're listening to music, or if you're me, you're like driving in a car or working out. And when you're watching TV, it's like generally a different time. But if you're like me, you might like watching this guy Billy Strings concerts on nugs.net. Which one you doing?
Both.
I don't know how they did that in the data.
You're watching
Yeah.
music.
We're going to finish up with your lesson summary in your packet here. Make sure you can summarize everything from the day, and then I'll give you your homework.